So last time we covered just how critical water is for, well, pretty much everything our bodies do, which leads to a really big question: how on earth does our body manage such a precious resource? Let's dive into the amazing internal control system that keeps our water balance perfectly in check.
And the main idea behind all of this is a concept called homeostasis. You can think of it as the body's constant, relentless mission to keep its internal environment stable and balanced. And believe me, when it comes to water, this is a full-time, 24/7 job.
A really good way to think about this whole process is like managing a daily water budget. You've got inputs and you've got outputs. To stay in balance, what comes in has to equal what goes out. Simple as that. And we're not talking about a small amount here. On any given day, a healthy adult processes about 2,500 milliliters. That's 2.5 liters of water. That is a lot of fluid to keep in perfect equilibrium. So where is it all coming from? Well, our water income actually comes from three main places. The biggest chunk, about 60%, is from beverages, no surprise there. But a pretty significant 30% comes from the food we eat. And then there's this last 10%, which is super interesting. It's called metabolic water. This is water our own body literally creates inside our cells as a byproduct of burning carbs, fats, and proteins for energy. How cool is that?
Okay, so what about the expenses side of the budget? The main way we lose water is through urine, which makes up about 60% of our output. But we also lose a surprising amount in ways we don't even notice. This is called insensible loss. It's water that just evaporates from our skin or that we breathe out from our lungs. The rest, of course, is lost through sweat and in our feces.
So who's the accountant for this whole water budget? It's not just one thing. It's actually this incredibly sophisticated team of organs, hormones, and enzymes, all working together like a smart reservoir management system to keep our fluid levels just right.
And at the absolute center of this whole operation are the kidneys. They are the master filters. It's pretty straightforward. If you drink a ton of water, they'll make more urine to get rid of the excess. But if you're not drinking enough, they'll work hard to concentrate that urine and save every single drop they can.
But what happens when the system faces a real crisis? For example, what if you get dehydrated and your blood volume, and therefore your blood pressure, starts to drop? Well, your body has a powerful emergency response plan ready to go.
When that drop in blood pressure happens, it kicks off this amazing chain reaction. First, the kidneys release an enzyme called renin. Renin then activates something called Angiotensin II, which is a powerful vasoconstrictor, meaning it squeezes your blood vessels to help jack that pressure back up. Angiotensin II then sends a message to your adrenal glands to release another hormone, aldosterone. Now, aldosterone's job is to tell the kidneys, hey, hold on to more sodium. And here's the magic trick. Because of osmosis, wherever sodium goes, water follows. So, more sodium gets reabsorbed into the blood, water follows it, and your blood volume goes back up.
The brain gets in on the action too. It releases something called antidiuretic hormone, or ADH, from the pituitary gland. The name says it all. It's an antidiuretic, meaning it works against losing water. ADH sends a direct command to the kidneys to reabsorb more water, which means you produce less urine and it's much more concentrated. It's a powerful water-saving move.
Okay, all this internal chemistry is fascinating, but how can we actually know what our hydration status is from the outside? Thankfully, our body gives us some pretty clear and simple signs to read.
Honestly, one of the simplest ways is to just pay attention to your urine. When you're well hydrated, you're going more often. The volume is higher, and the color is a nice pale yellow. But if you're dehydrated, your kidneys are in conservation mode. That means you're going less frequently, there's less of it, and the color gets much darker, like a dark yellow or even amber.
Now, you might be thinking, well, I'll just drink when I feel thirsty. And that's a crucial signal for sure, but here's the catch. Thirst is often a late sign. By the time you actually feel thirsty, your body's probably already in a state of mild dehydration. So think of thirst as more of a, hey, you're already behind alarm, rather than a perfect preventative tool.
So this system is brilliant, right? But what happens when it gets pushed too far one way or the other? What happens when the balance breaks down? Well, having too little water, or even surprisingly, too much, can both be incredibly dangerous. You've got two sides of the same coin here. On one side, you have dehydration, which we all know about. That's when you're losing more fluid than you're taking in. But on the flip side, you have something called water intoxication. This is much rarer, but it's a very serious condition where you drink so much water so fast that your kidneys just can't get rid of it quickly enough.
The signs of dehydration really show you that your entire system is feeling the lack of water. It might start with a dry, sticky mouth, but as it gets worse and your cells can't function properly, you can feel weak, you might even get heart palpitations, and because your brain cells are affected too, you can experience things like confusion.
So what's the fix? Well, for moderate dehydration, it's about more than just chugging plain water. The gold standard is something called oral rehydration therapy, or ORT. This is a special mix of water, salts, like sodium, and sugar. The sugar and sodium actually work together as a team to pull water into your cells much more efficiently, helping you rehydrate way faster.
Now for that other extreme, water intoxication. The real danger here is that drinking a massive amount of water too quickly dilutes the sodium in your blood. This condition is called hyponatremia. It causes water to rush into your cells to try and balance things out, which makes them swell up. And if this happens to the cells in your brain, it can lead to confusion, seizures, and in the most severe cases, it can actually be fatal.
So what this all shows us is that the body's control over water is incredibly precise. But water doesn't work alone. The whole system, especially that emergency response we talked about, depends on having key electrolytes like sodium. And that brings us perfectly to our next topic, the major minerals that are essential partners with water in keeping our body in perfect harmony.